Today we are going to discuss the problem concatenate non-zero digit and multiply by sum. Right? It's part two, and part one was the study questions. Right? And we'll see. We are given a string of length m, and this consists of digits. Right? And we have also given a 2D array LNR, and we have to extract the substring L to R, and we have to perform these two operations. That is, first is we have to we have to only concatenate all the non-zero digits and remove the zeros from that, right? If no non-zero digit, then we have to consider x as equal to 0, right? And we have to find the sum of all the uh, digits, right? And since 0 has no addition to that, that means sum of non-zero digits, right? And we have to give answer of each query in a vector. And since answer can be large, so uh, we have to return in the modulo of 10 to the power 9 plus 7. And and the constraints are s is s can go up to uh, 10 to the power 5, right? So uh, we can only expect the n log n, right? Or O of n or n root n, right? And QD can also is given up to 10 to the power 5. So we cannot do s into q, that will be 10 to the power 10, right? So we cannot do n n n or operation. We have to solve this QD in O of 1, right? So otherwise O of log n. So we will see the institution, right? We will go one by one how to approach this problem. So since first whenever we see any question, we have to firstly see that what was the constraints given, what is given in the question, right? And you should always write. If you not get the question correctly, you will waste your time uh, in just solving in the wrong way. So the first thing is to uh, understand the question and write down the points that are given in that. So firstly is given that we have to uh, from L to R, we have to do two things. Firstly, we have to remove all the zeros and take the remaining number that will form, right? And the second is that we have to take the sum of the digits, right? So we have to do two operations. Since we are we expect our solution to be this O n log n, right? S into q to n log n, and both constants are high. So instead of directly saying that, we will go from brute force, right? And we'll see how to do that, right? Because if you don't get anything, the first thing to do, that is the brute force, right? Suppose if you have given a number, this one, how you will approach this question? So the sum of the these is pretty simple, right? Uh, if you have, I ask you from L to R, what is the D sum? How will we calculate, right? So firstly, what we will do? Uh, Suppose you have to do in a in an integer manner, right? It is given as string, we can add from here to here as well, but this will take O of n time, right? So can we do this in if without converting to, I mean, by converting that to integer? So how will you do that? So to uh, see from here to here, we need the decimal places, right? So this is g 10 to power 0, right? This is first place, this is second place, right? This is second place, this is third place, right? This is fourth place, this is fifth place, right? So how I can do that? So what one thing can we do, right? Since we can make a count, right? So it will one, is two, is three, is four, right? So L is given from four to one, right? So how you will calculate the sum? You can when the count become one, you will start adding to the sum, and till when the count become four, you will stop, right? This is the pretty easy way, because all we have done the questions of reversing, right? How we traverse to the number is simple, right? We we take we take the num modulo 10, right? It gives us the last digit, right? And from the last digit, then after doing the operation, we remove that, right? And we'll remove this, then then we come to this one, and we will make a counter variable which will tell us the position. Initially, the position of this is 0, right? That is 0. And we can do count plus plus, right? So by this way we can find the position, right? This is pretty simple, right? And and the first thing is, second was to find the sum. Can we, like this, we can make also these. So we can, what we can do, we can take a variable number, new number, right? New number as 0, and we will at, when count becomes 1, right? When it will becomes 2, uh, L, right? It becomes L. Then we can start. Then we will start adding to that, right? So how we all have done the reversing the number, right? Most of us have done the of reversing the number. How we reverse the number, right? We were taking reverse equal to 0, right? And we found the digit, uh, right? And and what? Then we simply make the a place by multiplying into 10, right? For the new digit to come, and we add that, right? So by multiplying 10, if it was 3, then by multiplying 10, we make place, right? We make place for the new digit, and when we add 2, it got added to that place, right? So this was the pretty logic when we are reversing, and from the same logic we will make our this digit also. So when we are traversing in this loop, what we will do, we will simply do nothing but we just give a check if our digit is not equal to 0, then only in that condition we perform this operation, right? right? This operation will perform only in the case. That's pretty simple, right? So for in this is the very brute force manner we can solve this question, right? Just we need one loop. So let's summarize what we have done in our brute force, right? Firstly, uh, from we have to do operations from L to R. So what we will do, we are taking a counter variable to get the position, right? To get the position, and one uh, sum variable, so that will add the sum, and one new number variable that will concatenate the new integers, uh, right? We'll perform the new number by removing the digits. And second is that we simply loop through the digit, right? And and what we are doing, we are simply doing nothing but, while since since this is given at integer, right? This is not a number. So there is two ways uh, you can go and convert that to integer, but that will give you the integer length is 10 to the power 5, right? So it is very big number. So converting to the integer really very tedious operation, right? So what we'll do, we will just look from 0 to we'll suppose this was the digit, right? So what we have to, this is the 0th place, but iteration start from where? So we will start from reverse, right? What we will do, we will start our traversing from reverse, right? From n minus 1, and we go up to 0, right? And we will do the same thing. How we will get the digit? This is very pretty simple way. We just do this subtracting the character 0, right? This is the sky value, and this will give you the digit, right? And we do the same operation of uh, w- adding the number, right? So if we will check if digit is not equal to 0, right? We will simply uh, in new number, we simply add that digit, right? Very pretty simple, and we will add that digit to sum also, right? That's pretty simple. And this is the very brute force that, and its time complexity will be, so for the O of, so for one query, for one query it is traversing to whole string, right? Whole string. So that is O of n. And for the n queries, right? So it's uh, NQ, right? But it is also 10 to the power 5. This is also 10 to the power 5. So it is 10 to the power 10, right? And this will give us really, right? So now coming to the improvement. So to improvement, we have to just see what is our bottleneck. What is the one operation we are doing again and again, right? For the each query. Each query we are traversing from uh, from 0 to, through all the string, just to know that from L to R, right? L to R, what is the sum and the digits, right? So the pretty intuitive, can we do this in one go? Can we pre-calculate, right? Since we are, this is a very intuitive idea in programming, that when you are doing these same things again and again, can you pre-calculate, right? Pre-calculate everything, so that for the each query y- you don't have to calculate again and again, right? Can we do this? We'll see. right? So if the digit is given, right, like this one, right? So, and this is the positions, right? 0, 1, 2, 3, 4, 5. And suppose anyone asks what is the sum from 0 to 4, right? So range, suppose the query is this one. So for the sum, what we will do? Can we make prefix sum, right? What is prefix sum is nothing but we take a sum variable, a variable sum, right? And we add that digit, right? Suppose one, and sum will become one, and we will store in a that vector that till here the sum is one, right? And again when it will go here it will add, and some value will two, and will store that one, and then it will become 4, 4, 6, right? 7. So this is not, this is called prefix sum. This is pretty easy. Just take away some variable, and for the, and when you are traversing, just store that, right? So this is easy. When we have to, uh, uh, when we have to find sum for this query, so you have to do nothing, right? What this 4 represents? If 4 represents that from 0 to till the sum is 4, but you want the sum from 2 only, right? So this part is extra. So this part is extra, right? This is extra part. That is, what is this? L minus 1. So this is extra part. So we need only, it is given that from here to here, but we need that we need only sum from here to here, right? So this part is extra, right? So for this part, right, for for this part, what we can do, we can just subtract it, right? We have to subtract, then we will get that, and from here to here, where the sum is stored, this sum is storing this, na, from 0 to 1, right? So if we subtract, so suppose the array name is prefix sum r, and we will just subtract, we we will just subtract from the prefix sum that l minus 1, right? We will just subtract l minus 1. So we will get the sum, right? And one condition can be if l is 0, right? If L is 0, that is the edge case, that we want sum from here to here, but nothing is to subtract. So we just put an condition that if L is greater than 0, then only you do this. Otherwise, nothing to subtract, 0, right? So this is pretty simple. This is prefix sum, and for any sum, if you have to find the sum of the range again and again of the same vector, and the array is not updating, right? So there is not changing. So you can always use the prefix sum, and it's pretty intuitive. Whenever you are seeing that you want a sum of a range, right? Nothing blindly you can uh, apply the prefix sum if it is not changing. It is very helpful. And now we have done the one part. And is the second part is we have to find the digit, right? Digits containing non-zero, right? So let's think about how we can pre-calculate that, right? So if you have given digit, so sorry for the disturbance. So we were discussing that. So we have completely do our the done that our the first task that was finding the sum of the digits that we have already done, and we remaining with the we have to find the uh, digit, right, the new digit that will form after removing the digits, right. So suppose this was the digit, right, and you have given L to R, that is from 2 to 6, right. 2 to 6, this is the question, right. And and you have to find out that we have to make the deals, right? So we will just simply see how we can solve this. So wha the thing that we were doing by going from uh, here to here, right? We start from here and we were just checking that. So it was 0, 1, 2, 3, right? 4, 5, 6, 7. So when it's become 0, 2, we start our adding to the our number, right? We take a variable new number, right? Sorry. So we are taking our variable new number, right? And when it starts that it comes in there, we start if it is not 0, right? So we will not add. So uh it is non-zero, so we will add. So it's 0, will not add. So it's 2, right? So we will multiply 10, that will make the place, and we'll add 2, it becomes 22, right? And it comes again to we again multiply and we do that too, right? So it becomes 22 and it's go out of the range, so we stop, right? If you see that, suppose you know the range, right? Suppose you know the range. So how can you find this number? How you can find this number from the whole number? How you can do that? Think about. Can we think of that if you know that this is how much, this is fifth place, right? So it's 10 to the power 6, right? So this position is 10 to the power 6, right? Suppose we will take a smaller number, right? It's too big. Let's take very smaller number, that is this one, right? Okay. Suppose I want that last three digits. How you can do that? And if you have we have done this, we have already solved that when we are given and we want this last digit to reverse the number or to palindrome, what we did nothing but we did modulo 10 and it gives this remainder. Suppose if you do the modulo 100, what will the remainder come? That is 21. And when we do this remainder 1000, what will come? 221. So suppose, so see, by taking the modulo, we are able to get the starting from the last digit. Are you agree with or not? Right? If we know that what is the place of that digit, so it's we want three digits, right? Three digits. So we have to modulo with 10 to power 3. If you want the last four digits, we'll do the modulo with 10 to the power 4. Did you agree or not? Yeah, this is pretty simple, right? We can get the uh, the number from 0 to till that index, right? So 0 to 5 we can get easily. by doing the modulo 10 to the power 5. So we can get this number easily by doing 10 to the power 5. But- And you think you get this number, right? Now you have to take only this number. This is our range. This is extra, right? So if you if you think yourself back, right? So we have done this question also. We have already done this, and this approach also come from n- nowhere but the same things we do with our palindrome or checking the palindrome number or just finding out the reverse of the number, right? So if we are given one to one, right? So we were checking by doing modulo 10, right? It gives a one, the last digit, right? And for the further, we divide number by 10 to remove this digit and number becomes 12 so that we check that again, right? So, so we get this number, right? So, and suppose we want only from here to here, right? We want only this number. We have to remove this number. So, to remove one digit, we divide it by 10. Suppose if we divide it by 100, what will be the quotient? That is 1. So, this we can we can remove this by doing 100, right? If it is 2 to 1 and we have to remove this 3 digit, if we divide if we divide it by 10 to the power 3, that is 1000. So it will comes 1. So we are able to remove this. So this is pretty easy, right? So what is comes, right? So we just need to know the position, right? The position of the digits, right? So in this number, this is the number, right? We have taken. So we will write here, right? So the number was 1, 2, 0, 2, 2, 1, and we just need to know that what is the position, right? So it's 0, 1, 2, 3, 4, 5, right? It's 5, right? And we just need to know. Suppose we want this this two digits, right? So what we can do? We will do nothing, but this is our number, right? So we will we will just uh, do the modulo with 10 to the power 4, right? Actually, it's 10 to the power 5 because it's 0 bit base index, right? So we have to take 10 10 to the power 5, right? So this number we extracted, right? And since this digit extra, right? So how we have given range 4 to 3, right? This we know. We just add one, right? And we will get the from 0 to R, right? 0 to R we have get. So we have to remove L minus 1, that extra. So L is given as 3. So what will be the L minus 1, right? L minus 1 will be nothing but 2. So we have to divide by doing 10 to the power 3 because it's 2 plus 1 due to 0 base index, right? So we divide. So this will go enough and we will get our digit 20. Pretty simple, right? So now see what we are doing. So we are confirmed that if we know the position, we can take our digit. But in the question, we have to, told that we cannot take zero digits, right? So we need to avoid the digit, right? So how we can do that, right? We have to avoid that. So what we will do that in this, instead of storing the index, right? We will just, if it is given 1 to 0 2 to 1, right? So we will store the count that this is the valid one, 2, right? Is 3, and since it is 0, it is not part of the new number. So we will not increase the count because this is remains same, and this will become 4 and this will become 5, right? You agree with me, right? So and what we can do that we will form the number from starting, right? We'll take an vector, right? We'll take a vector and we will start making the number, right? So how the number will look like, right? So number will look like it's 1, right? It's 1 2. So we should start with 0 position because number starts from 0, right? So it's it's 1, it will be 21, and from here it will 221, and from here, since it is 0, we will not include that, right? So the valid answer is still to 221, and still here it will be 2021, and from here this is this number will form. So we have stored in our array the valid number, right? From 0 to that index, right? Now, if anyone asks me that give me the number in the range 4 to 5, right? This is the range, these two numbers. So what I will do, right? I will just go to 5. This number is 2 2, right? It's 2 1. It is formed from 0 to 5, right? And then we will discard the number, right, from the index 3, right? So this this number have to discard it at 3, right? This number. So this is the extra, right? So this number is extra. If you see that this number is extra, right? And this is L minus 1 we have stored. So how we can remove that? We have, if you think that we have stored the count of the valid digit till that number, right? To discard, right? To discard that number, we have to do nothing. How we discard it? By dividing that number by 10 to the power that place, right? If we divide by 10 to the power 3, it will be discarded and we'll get our answer, right? Now, let's do one more example, right? Suppose I want from a, the the question is getting from 3 to 2, right? 3 2, right? 3 to 2, right? Let's, so we'll see at 3, right? So at 3, it is stored 0 to 3. The valid number formed from 0 to 3, right? So that is 221, right? But it's 0 to 3, right? This number is 0 to 3 in range. but we want only 2 to 3. So we have to discard the number from this one place, right? Right? So it's 0, 1, 2, 3, right? So we have to discard this. So we have to discard how what we have already stored 21, right? And since it is it is stored in the form of number, we don't know what is the size of this. So we have already stored that information extra also in a vector, right? And we know that its digit length is 2. We have already stored that. So we have to discard this 21 by how we can discard? Just is dividing it by size. That is, we have already stored that is 10 to the power 2. So we do nothing but just divide it by 10 to the power 4 and just this. And we, by dividing 10 to the power 2 and just we'll discard last 2 and we'll get our number. And if you see that this is nothing but uh, is it is this one, right? It's 0. It is 0 being the index, so it's 2 and 3. So in 0, so it is 3 comma 2, that was 0 2. So valid will be 2, and that is our answer, right? That is our answer. So let's summarize what we do. So for the our second to find the valid digit, right? We are doing nothing but we are storing two things n into two vectors, right? First thing is we start from n minus 1th position because it is given from as a string na. So string start from here, but the the zeroth position, zero power is zero. The first place is this one, second place is this one, right? One place, tens place, 100th place, start from here. So we have to start from n minus 1, right? We have to start from back, and we are storing the valid number from 0 to till that index, right? So we, we are taking, suppose it is of vector 4, size 4, this store the valid number, and since we are storing the number, if it, since we are storing the number, we it will, it takes O of n to find out the length, right? It takes O of length to find out the what is the length of the digit, right? Since it is 10 to the 5, we cannot do operation as a by traversing on the string again and again. We have to do in O of 1, and we can do that easily. We are also storing the size of the digit, right? So we are taking two variables, that is count. We will store the size of the digit and the number form, right? And we start. So so it's the valid number, and this will store the count, right? This is for the count. So if we see here, the number is formed 1 and size is 1, right? And let's put 1 0 as well, and right, increase this. So and is 2 is 21, its size is 2, and is 0. This is not valid. So we'll not add it, and our valid digit will remain as 21, and its size will remain as 2. Again, it's come 2. So digit will become 221 and size will become 3. And at last, it will become 1, 2 to 1, and the size will 4. So we are storing this size also. So why we are storing the size? We have already discussed to remove that the some digits, suppose we have to remove two digits, so we need that from this index we have to remove, right? So we to remove this number, we just need to know the what is the size, and we will just subtract from that number this 10 to the power size, and that will be removed, and we will get our answer. So that is for the second one. So let's summarize how what we are doing, right? So the summary is, and there was two things. First, we need the sum of digits, right, from L to R, and we are doing for the L to R, right? And we need the valid digit formed. So for this, we are making a prefix sum vector, right? Prefix sum vector is nothing but we are storing the sum, right, in a vector till that index from 0 to that index, right? And for this, we are storing two things. First is the count of the valid digit from n minus 1 to that index, right? Because our zero place decimal place start from this side, right? So we are storing from here what is the count, right? And and in another vector, we are storing the valid number from n minus 1 to that index, right? Valid number. And whenever we get any query, we do nothing. Just we if we get query from L to R, we do how we form the number. Number forming is very pretty easy. The valid number uh, that we have formed, we do R, that will give us the valid numbers, right? And we just subtract the the number we don't want. So we have to subtract the valid L minus 1. So how we have to remove this, and how we are removing, by just doing nothing. To do this operation, we are just making what we are we are just dividing that number, this number. So here I have think about two approaches here. Firstly, let's do what we have discussed. We are dividing that 10 to the power by uh, power of 10 uh, by size of the digits, right? The count we have stored, right? Power 10 beside the count of L minus 1, right? The count of L minus 1. But here the problem is, this is pretty simple. But the problem arises because we have also given that we have to do modulo with 10 to the power 7, right? So 10 to the power 9 plus 7, we have to take the modulo. And we know that we if we do modulo here in division, so we cannot do directly division in modulo, because division, so if we have to divide now, suppose it is 10 by 2 mod 2, right? So it's 5 mod 2. This is not how it works, because there is some answer will be different in the division. So we Sorry for the disturbance. If you don't know our Fermat's-Liti theorem, it's nothing but if you have to divide by 10 mod 2, right? You do nothing but s- you do nothing but you do 10 mod 2 into you just do the to the power what is the mod 2 minus 1. So here it is and mod 2. So here it is given the m is 10 to the power 9 plus 7. You just do nothing but you just multiply the mod with 2 the power m minus 2 mod 2. So this is to find the power. It also we can use the binary exponentiation. That is, or we can store the power of this one, but that is very overload. So there is a one more slightly change in our approach, right? That can save us from doing this. So since since we know our since we know since we know that, so we have to remove this. Why we are dividing to remove this? If there is an another way we can remove this. Think how. So we know that the size of the digit we have stored in our count array, right? We know the size of this is 2, right? And this is 4, right? We know na. So things is pretty simple, right? How we can do that, right? How you can do that? If you if you think we have stored, uh, let me show you here, right? So what we have stored, right? For this digit, we have stored that it's 1, it will form 2 1, it will form 21, 221, right? And 221 is 2 to 1, right? Is 1 2 to 1, right? So and L2R is given from here to here, right? And we are calculating from here to here, right? So we know the count, right? So if it is given that 4 to 5, but our answer is stored as at 5 to 0, right? From n minus 1 to that index, right? So if it is given 4 to 5, so so it is the fifth number, right? And this is the fourth number. So this is the fourth number, right? So fourth number is 21. Let's take third index, that is 1 2 to 1, and the fifth number is the 3 to 5. So second is 0 to 2 will be 221, and it is 21, right? So it is 5 to it is R2, uh, it is 0 to R. This is 0 to uh, n minus 1 to L, and okay, sorry for the lag. And let me see what we are discussing. We are discussing the another approach, right? So the another approach is from in this approach where we are start storing the digits from the last, right? So we need to remove the first this digit, right? And we need to remove this well also, right? It is storing from, if we get L, we are getting 3 to 5, but we need only 3 to 4, right? So it is it is fifth index, fourth, third to one. So in 1 minute. So we need to, let me correctly write the indexes right so that we can discuss fairly. So it is it is zeroth index, first, second, this is second, this will third, fourth, fifth, and this will the sixth index, right? So we need 3 to 5, right? And we are storing from here. So if we see the the valid 3 will give us, that is 221, right? That is the valid number from till here. And we need to remove this one. So we have to always we have we have to always divide this number by this count, right? So there is another approach where we can do this. That is, instead of storing from last, what if we store from the valid digit from zero, right? From this index. So what the number will form like? So it will be one, it will be one two, it will remain one two, third, 0, 1, 2, 3, 4, 5, and 6, right? So it is 1, 1, 2, right? And it will, since it is 0, it will remain 0, and here t 2, so it will become 1, 2, 2, and again 0, it will remain same, right? And and here it is again 2, so it will become 1, 2, 2, 2, and at last it will become 1, 2, 2, 2, 1, right? Now see, if you want digit from 3 to 5, you can directly take till 5, right? This one, right? If you take 1, 2, 2, that's you have get, but you have to remove this valid pair from here. So you need to remove this one, this number, right? Because we want here to here only, that is 3 to 5. So how you can remove this one? So you already have stored the count of the valid digits in our counter variables. So this is size 1, is 2, is 2, is 3, is 3, is 4, right? So we if we subtract this this we know, if we come to know that, let me give you pretty simple example. That is, if you have 1 to 1, if you subtract, if you see that, to get this number, we are just doing what? We are we we are just getting the size, and we are multiplying the remaining number by 10 power that, right? So we want this two number size is 2. We are doing nothing. This is the remaining number, that is 1. we are multiplying 1 into the size, right? So earlier our answer was was the after division, what is the remaining, that were answer, and we have flipped that instead of dividing, we are just finding out so this number, and we are removing this number. So we need to know the size. So how we can know the size? So at 5 the size is 4 and this 2. So if we do 4 minus 2 is 2, we get this size, right? And we do nothing. So L minus 1, we know that this digit already stored. So we are just doing valid L minus 1, right? And we will just multiply the size of the valid pairs that we want, that is 2. So what we are doing, if we have 2 2, we are just subtracting 1200, right? And it will give us 22. See, we get, earlier our answer was the remainder. Uh, After division, our answer was the quotient, right? We are dividing by 10 to the power 2, right? And this vanishes because we stored from last, but here we are storing from this position. So this is the highest power, right? Eh, MSB, if you understand, right? Most significant bit, right? So this is the most significant place, right? Earlier we are making our deals from least significant to most significant, but we are in this, we are doing from the most significant to least significant. So so if you understand, this is pretty simple. We are just storing the number from here, and got we are asking in the range L to R. We are just do nothing, but we are taking the valid R, right, which gives us this number, but we have to uh, subtract the extra MSB, right? And because our answer lies here, we are just doing nothing, but what is the valid L minus 1, right? That is the L minus 1 number, that is this one. Let me uh, write it clearly. So, so this was the valid R, right? And from valid R, we are subtracting the valid L minus 1, right? The extra part, that is this one, that is 12, that will be stored in our vector, right? And we have to multiply it with 10 the power, this one, right? So we just multiply by its size, right? So its size will be stored as 4 at RS position, and at LS position it will be stored as 2, size is 2, so it's 2, and we will just multiply by the size of our answer, and it will gives us our resultant answer. That is pretty simple, right? So let's see what we are doing. So we are just storing the valid number from from zero index in given string, right? We are forming our two ith string, right? Ith index, the valid number, right? And the count vector store the size of the digit, right? Size of the valid digit. And how we are getting the answer? Answer is nothing but from valid R, we are subtracting the valid L minus 1, and since it was the MSB digit, we need to give that power. So that power, we are doing nothing. We are just multiplying 10 to the power whatever the count of the R minus this count of the L minus 1. So if it is 2 to 1, right? So this is 12, right? So we get at L minus 1 is 12. But we have to make it the significant is place, right? So we have to shift it by two position, right? So we are just to shift, we are multiplying this so that it becomes 1200. It will go at this place where it exists, right? And we are just subtracting it and we are getting our answer. That's pretty easy, right? So, and for the sum we have already discussed. So now you see that earlier what we were doing earlier, we were subtracting our answer from 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 10 to the power the size, right? The size we we want to remove, and we were doing modulo. So, but division was a problem. We have to use format splitting theorem for, and that was an overhead, right? So, instead of doing that, we started from our storing our answer from start, and now our answer has changed. We our we are doing nothing but L to R, and we are subtracting valid L minus 1, and to give its right position, we are just uh, doing the size that is count R minus count L minus 1, right? That gives us the size. So, and we have shifted our uh, answer from division to here multiplication, and now we can easily do the modulo, right? So this will makes our answers simple. So that is the crux idea, and let's see and go and see the code, right? So since we need the power, since the constant the size is given as 10 to the power 5, so the sum can go up to 10 to the power 10. So we are taking as long, right, for the sum. And since we have to calculate the power again and again for each value, right, for each size, and the largest size can be n. What will the size of the largest digit? That is from 0 to n minus 1. That will be the n size at max, right? So we need only at max 10 to the power n size. So we are doing n plus 1, right? Because of the zeroth index, right? N plus 1. And we are storing the power, right? We are just doing nothing. We have said 10 to the power 0 is 1, right? And we are taking from I is 10 to the power 1, right? Ith power will be 10 into the last power, right? And we are taking modulo because we have to do modulo. And we are taking a variable number, will store the valid number from that zero index. And we are taking a variable new int that will uh, the store the for the ith, right? And there we are taking three things. So the three things that we needed, right? That were so for 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 zero, we are storing the valid number, right? Valid number form, right? And for the second, right? For the second, we are storing the sum, and for the third, we are storing the size of size of the number, right? So initially, the sum will be the what is if it is some if num is zero, if this position is zero, so zero. If it is not one, so si minus zero, that will be the number. And count is if if it is If it is not zero, then it's one. Otherwise, the size will be zero because no valid number is formed, right? Right. So that is, and so we are storing at zero place the valid number, and at one place at one place we are storing the sum, and here we are storing the count, the size, and we are starting from one, right? From here we are just checking the digit. If it is positive, then we are increasing our size of the digit, and we are just multiplying in 10 to make the place, and we are just adding that digit, and we are taking modulo because we not want overflow, right? And in sum also we are adding our digit, and for that index in our new int vector we are just storing all three information, right? And after pre-processing it, we go to our queries, and we are starting L and R, and sum is nothing but from R to L minus 1, right? We are just subtracting, we are getting the our answer. And for the valid number, we are doing the same operation. We are taking the valid R, right? And we are uh, taking the valid L minus 1 number, and we are multiplying the power, right? That is the size till R minus size till L minus 1, right? And we are multiplying with power 10 to make that place, and we are just subtracting, and that will give our answer, right? Since we are subtracting it, right? So answer can be go into negative. So to make that positive, we are doing the plus m, and doing the modulo m. So this is pretty easy because we have to check every multiplying our or adding you are doing in modulus. So we you have to always do modulo at every step here, so that there will no even one single chance of overflow, right? And after doing that, we have to store the product of the sum and the valid number. So we are doing the product and storing in our answer, and we are returning it, right? So this is the pretty easy code, right? And and we have seen here three things. That is, first thing was the pre-processing, right? And that pre-processing was uh, and is always, if you see any question that is not updating, or there is a query, pre-processing is must, right? For queries you always have to do pre-process, so that you do not have to calculate for each query, right? So we do two pre-processing, one for the sum, right? And as and the valid number. So this is the pretty template, you can say, for the queries, that you just have to think that how you can pre-process this given thing, that for the each query you have to not do the operation again and again. That was the crux of the this question, right? And we handle that in two ways. One was by dividing, right? We were starting from the last, and one is how we optimize from starting from starting, and we don't have to do the uh, modulus problem of division, right? So that was a pretty easy question. And when if you don't understand the question, take a pen and paper and try to write down this question by taking the small integer, right? And this was a very pretty good problem, right? And this was a study question was also see, this was easy question, and the constant was very low, right? So n can go up to 10 to the power 9, at max 9 digits can be there. So the same thing we are storing. This was the brute force, right? We are taking the sum, and we are taking the num variable, right? We are storing the number, right? And since when we store from the last, right, it will 4, 3, 2. So it is storing in reverse, right? So we have to again reverse back, right? So we are again reversing back, right? So we are after forming the valid number, we are reversing it, and once we formed our number, we are just multiplying it, right? That's pretty simple, right? So hope you understand the question. If you don't understand, please take pen and paper and dry run it by your own, and you will understand it. Okay.